guys, leftover chaos from the pipsqueak receiver that I just built. Tonight I'm gonna do a video on the little radio that I was updating you guys on there last couple of days. And tonight I'm gonna sit down for an hour or so and see what we can do with it. But first, gotta clean up this mess. Oh my. And just like that, we got another project. This phone is the ICOM IC-229H. The radio belongs to a friend of mine, and the poor radio was just begging for some personal attention, for sure. Just begging to get some help done on it. So we got some really long screws in there. So I'm going to end up replacing these with the proper screws in the side of it. The power cable has pretty much in whatever. They got the big Kenwood power plug put on this thing, taped up right to the back of the radio. Tie wrapped it on because there's just too much weight. I wonder why. I mean, this, eventually that's going to cause issues there. Then we've got the microphone connector. That was all taped up. I removed a lot of tape, but the connector itself is pretty much busted. As you can move the whole thing. I don't know if you can see that. The connector itself is broken, so we got to get another shell put on that, fix up the microphone, and put a new power cord on the radio. So, yeah, got a little bit of work ahead of me. I was going to start this last night, but I was busy last night. I was really busy at work, so kind of time I gets home and everything else, I'm really not much in the mood, if you know what I mean. But it's a little bit after 9 there now, so I'll put an hour on it and see what we can do. Anyway, if you're interested in it, this is the ICOM IC-229H VHF mobile radio. So let's see what we can do to purdy this up a little bit, eh? So this radio comes with an SO239 pigtail for the back of the radio. It's normal, and this is what happens when you tie wrap your cable to your heatsink. Especially heatsink gets very hot, and heat melts rubber and plastic. Well, what do you think is after happening here? It was actually starting to melt the rubber coating from the cable here. So it doesn't look like it's gone through yet, so that's good. But yeah, not good. There's a reason why you don't tie wrap it on, but anyway. You got this cap. Pretty sure, yeah, that's not even flush. So this was an add-on, which leads me to believe that the connector on his radio has been replaced. And the shield got some give in it. A little bit of give anyway. Might end up having to put a new connector. I'm interested to see what's underneath this rubber. See how this was even crimped. That looks rather interesting. I gotta have a look at this. This has definitely been replaced. This connector is definitely a replacement. And as we can see, the connector actually got some give. This shouldn't be moving like that at all. So that connection there is going to give out sooner or later. So we'll see if he wants me to replace this connector. I think it should certainly be replaced, because there's a failure there waiting to happen, definitely. I'm hiding it with the heat shrink. Anyway, I'm going to be replacing this part of it. Let's cut the tie wrap, pull this tape apart, and I can only imagine what I'm going to find underneath this. Let's have a little peruse, shall we? Well guys, I got the power cord, the old piece of junk removed from it. I now have this Motorola style power cord put on the radio. I got a new power cord made up for him, the matching plug, put a couple new crimps on the end of it, put a new fuse holder and new length of wire. So I got that done. I replaced the mic connector, this steel part here. What happened after I moved the tape, where this part here was actually snapped, it was broke clear altogether. So that's why the connector was moving up and down when I moved it, because the connector itself was broken. Now, how would you manage that? I have no idea. But I unsoldered the whole connector and everything and redone it again, and now it looks a lot better without 300 miles of tape, electrical tape on it. So I got that fixed up. So the next thing is this connector here. As you can see, this very, very poor. Shield all broke clear, and like, you know, how's this supposed to work? Got like what, 3 or 4 strands maybe? So we're going to replace that one with a brand new connector. We got one here, brand new one, I'm going to put on. You want me to get a new connector for him, so there's a brand new one. So I'm going to put that one on and remove this one. Remove this, remove that, and replace this connector. Alright, gotta love it. Okay, that's the old connector removed, chopped off. It's the old one. And if you've never seen this, this is the 3 parts of this connector. You got the main body of the connector here, you've got the pin and the ferrule. So the pin goes on your center conductor. It's got a little hole in it, so you can solder this pin onto the center conductor, which is what I'm probably going to end up doing, is soldering it. And then that pushes up through the connector, which locks into the center connection right here on the inside. Not sure if you can see inside there. See that pin way down the center? Like female connection. Well, that's what this pin mates into. Down there. So anyway, let's get this connector put on. So, you got the connector, and basically this is how you prepare the end of the cable. So I need to shorten my center a little bit. I got a little bit too long. I find the best spot to put that for these connectors is right on the end of the thread, right at the beginning of the thread. So I've got to shorten that pin a little bit, probably about maybe 5 millimeters. Just that by about 5 millimeters, and we should be right in the sweet spot for that. Okay, so I have my pin soldered on. So now I'll just take this part and just stuff it up inside of there and push it all the way down to lock it in. That's what you do with that. And you put the ferrule on, crimp it all down, and put a bit of heat shrink over that again, and we're good. Okay, so here we go. Brand new connector on. The whole cable moves, rotates now, and so I got a nice solid connection. And I'll just take the heat shrink that I added beforehand and slide that up, shrink that on. Now we've got it replaced. There's the old one. There's the new one. Okay, so there's a couple little modifications the radio can do. It can receive the airband from 118 to 136 megahertz, and you can also expand the transmit from 136 to 174. So what I'm interested in getting demodding is this one. To expand transmit 136 174, locate chip diode D9. Ascertain that the vertical pair of pads to the right are open. Short the next pair or vertical pads to the right with solder, perhaps. Whatever. Anyway, chip diode D9. So, looks like we got to reattach D9. And apparently, this is what it looks like once I open it up. IC4, D3, 4, 5, 6, 7, 8, and 9. So D9 on the front of the radio is the one I have to re-enable. What are we going to get ourselves into here with this ICOM IC-229H? Okay, guys. So again, we're on the ICOM 229H, and we're going to demodify this radio so it does not transmit outside the emitter band. And as we can see, there is the culprit diode. D5 has been cut. So I'm going to re-enable D5. But definitely closing D5. And while I'm in here, I'm going to see if I can replace one of these bulbs. I think I might have a spare one there. If I do, I'm going to replace the bulb while I'm in here. But D5 right there. So we're going to resolder that. Probably end up going to have to reset this radio, obviously. But let's so the diode, the pin, the lead's just been cut and separated. So should be an easy enough repair there, I'm thinking. I just checked both bulbs, this one and this one. Checked both of those on that multimeter, and both of the bulbs test fine. So not sure. Well, one's not lighting up. I resoldered it anyway. Could be just a bad solder joint. So we'll find out now when we reassembles it. Anyways, got D5 has been resoldered here now. Now I'm gonna put her back together and see what happens. Probably gonna have to reset the radio for this to take effect, but maybe not. We'll see now shortly. Hey boys, got a little correction to do here. I said earlier D5 probably done the full transmit, Mars, MOB, whatever you want to call it. D5, this one here, actually opens up the earband receive, D5. So I'm going to reopen this diode because my buddy wants to be able to receive earband. But to actually enable all transmit, it is, let me see if I get my screwdriver in the picture here. There's a little jumper right there. My blade, screwdriver blade on that jumper right there, a little solder blob. That's what needs to be opened up. To enable full transmit, you solder this, you put a solder joint across here, solder blob. ICOM refers these things as coffee beans. But anyway, you open this up and that puts your transmit back 144 to 148. So I'm going to desolder this solder from here. I'm going to open up D5 and reset the radio, and she should be good to go. Okay, so I have earband receive, D5 opened up, and the jumper, coffee bean, right here, has been opened up. So now the radio will not be able to transmit outside the 2-meter band. So I'll show you that now shortly, how this works, and we'll see what happens. And she's apparently she's not supposed to be able to transmit on the earband with that diode cut, so we'll find out. But hopefully, if it will do transmit on that, then I'm definitely going to be closing D5 again. But we'll put her back together and we'll give her a little test, see what happens.
Saturday, January 21st, 2023. Tonight, snow at times heavy and blowing snow. Amount 15 to 25 centimeters. Wind northeast 50 kilometers per hour, gusting to 70, becoming north 50, gusting to 80 early this evening, then northwest 40, gusting to 60 overnight. Temperature steady near -1.
Okay guys, I've done a little bit of research on the radio, and apparently at the time, I mean, this radio was made in like early 1990s, and apparently even from the ICOM's manual, the radio is guaranteed 144 to 148 megahertz receive transmit. Now, these radios, this particular model, this ICOM IC-229H, apparently transmits from 140 to 150 megahertz out of the box. Apparently that's normal band coverage for this for the transmitter of this transmitter. I guess that's for the Mars users. So kind of find it strange that ICOM would leave the transmit open that wide, but it is what it is, I suppose. But I tried putting the earband modification on this one. It did take it 118 to 136 megahertz, but the receiver is it's as wide as a barn door, and it has a lot of intermod problems on the earband. So I just took it back out of her again. It was just even listening to the tower here on 128.000 megahertz ATIS, I was even getting the weather broadcast from 162 megahertz down on 128. So intermod is quite heavy on the airband for this. If you got this radio opened up for that. But anyway, that concludes the fix up and repair for the ICOM IC-229H. Hope you enjoyed the little run through with all of this and what I had to do with it and stuff, and we'll see what comes up on the next video. But there we have it. Hope you enjoyed the video, folks. All the best, and we shall chat later. It's raining not to 63. We're out of here. 7-3.